Our next topic is specific learning disorders. Now, these are defined as deficits in performance of academic skills that are well below what you would expect on the basis of the IQ level of the individual. It's also important that you rule out sensory deficits. A child, for example, with visual problems is going to have severe problems reading, not because they're not capable of reading, but because they can't see the words clearly on the page. Once again, I want to emphasize it has to be significantly below expectations. All of us have topics that we are better at than others. Some are good at math and poor at reading, or great at reading but not good in math. So it has to be dramatic before we call it a learning disorder. Typically, we specify the nature of the learning disorder. In most cases, it will be specific, such as a math problem. Learning disorders are far more common in males than females. There may be partially a bias there in that males are more likely to act out when they're having difficulty in classes. But it appears that that bias couldn't possibly account for the differences that we see. What's behind learning disorder? What are the causes, or at least the contributing factors? Genes and neurobiology are both implicated. Genes are clearly involved. There's no doubt about that based on the evidence. But curiously, learning disorders don't seem to run true genetically. So parents, for example, might have a math learning disorder, but one or more of their children might have a reading learning disorder. Learning disorders seem to run in families, but not specific learning disorders. Also, the disorders are complex and they show different symptoms in different people. So it's hard to tell, for example, whether a reading disorder is a specific disorder shared by all people with reading disorders or variations on a theme. We have identified several specific genes. That's further than we've gone with most other disorders covered in this course. And we're clearly aware that learning disorders are part of a constellation that we're going to call subtle brain damage. Okay, subtle means that it's not dramatic, but that there's evidence for brain damage in several often overlapping areas. We see that, for example, that learning disorders are often comorbid with things like ADHD, attention deficit hyperactivity disorder, and conduct disorder, both of which we're going to be covering in this chapter. Also, environment contributes. Language disorders are found in just about every culture, but they're far more common in English-speaking cultures because English is a much more difficult language to master. In English, there are more exceptions than there are rules. And so many children have difficulty with language if they're right on the border of being skilled in that area. This slide is covering material that's not covered in the book, but it's exciting. It gives you an idea of something that might make a huge difference. Let me describe the study. What you're looking at are brain scans. In particular, these are brain scans that show activity level for two different groups, a group of individuals who experience dyslexia, which is mostly a reading, to some degree a writing disorder, and control subjects. And what they're doing is they're either observing a pattern that is fixed or a pattern that is in motion. And their job is to process that pattern. Now, on the left, above is the controls, below are the dyslexics. When they're looking at a stationary pattern, you see activity in the back part of the brain. Now, the back part of the brain is called the occipital lobes, and you're seeing activity there because The occipital lobes process visual information, what your eyes see. And you see that there's basically no difference between the two groups in what's activated. But put a pattern in motion, and people who do not have dyslexia are still processing a visual image. So they're doing it in the occipital lobes, but they're also doing it in other parts of the brain, specifically the parietal lobes on both the right and the left side. You don't see that in dyslexics. They seem to have a breakdown in the brain activity needed to process information when it is in motion compared to when it is stationary. Now, what difference does that make? Think about how you read. You read by moving your eyes across the page. Actually, you move your eyes in jerks, and the reason you do that is your eyes don't process information very well unless they're momentarily stopped. So when your eyes are moving, everything's a bit of a blur. So what we do is we move our eyes, we catch a word or two, and then move to the next line, etc. Now, if you've ever been in a car and perhaps looking down and suddenly realize you were moving and you slam on the brakes only to realize you already have your foot on the brakes, what's happened there is the car next to you moved. And because it was moving relative to you, you incorrectly interpreted it as motion. It wasn't motion really, because you were stationary. Well, when your eyes are moving, you incorrectly can interpret that as motion. In fact, if you drink too much, what will happen is you'll develop a nystagmus. The eyes move slowly in one direction and then snap back when they get to the end and then move slowly. But you're not aware of that motion or the eye movement, so what feels like is that the room is spinning in the opposite direction of the nystagmus. It may very well be that part of the reason why individuals with dyslexia have difficulty reading has to do with the way they process motion while they're reading, motion that's created by the movement of their eyes. So is there anything we can do about that? Well, not with printed pages, because they're going to have the words across and they're going to have motion. But you're looking at this on a computer. On a computer, you can present information in any way you want. One way to present information is to put the words one after another in exactly the same location, so you don't have to move your eyes. In fact, that's a relatively easy thing to do, and it's possible that with technology we can erase or dramatically reduce the effects of some learning disorders. Now, this is cutting edge, not clear to work, but it's an exciting possibility. Typically, we treat learning disorders with more practice and more drills. We focus on the disorder that the person happens to have. So if it's a language or reading learning disorder, we will have them do a lot more reading and work on improving their reading. If it's a math disorder, we'll have them do a lot more math problems until they do it well. Drills, even for things that you're not very good at, you can get better at it. As I just showed you in the previous slide, there's some promising work that may lead to treatments that are much more effective and don't require so many routine drills, which, by the way, can be pretty boring for the students. Drug treatment has been tried for several learning disorders. Drug treatment when the learning disorder is comorbid with ADHD is moderately effective, probably because it controls the ADHD symptoms. And as you're going to learn, learning disorders are very common in children who have the diagnosis of ADHD. I'm going to cover several other disorders, but I'm going to cover them very briefly. simply because they are included in your textbook. One is developmental coordination disorder. What we have basically are individuals who are just clumsier than most of their peers, which means that they don't move smoothly, they're likely to drop things. At sports, they're not very good. And their handwriting sometimes can be atrociously bad to the point where they themselves can't even read it. We don't know much about this, and quite frankly, we haven't been studying it for very long. Such developmental coordination disorders tend to be parts of these soft neurological syndromes where we have many symptoms present. Stereotypic movement disorders can occur as part of other neurological disorders, but occasionally they simply occur in individuals who don't show any other serious neurological signs. Behavioral methods have shown themselves to be moderately effective. We tried a variety of medications. We often use medications when we have neurological problems that provide such stereotypic movement, but in stereotypic movement disorder, where there are not neurological functions, the medications we've tried at least don't seem to do much. Tics are involuntary motions, and usually they are part of a neurological condition. In one disorder, Tourette's disorder, the tics tend to be what we call coprolalia. In English, those are outbursts of words, usually obscene words. But in some cases with Tourette syndrome, you get not words, but just sounds that are tic-like. They come, they can't be controlled. They are more pronounced when you are not trying to control them. In many cases, you can control them, but it takes so much energy that you can't do much thinking. We also recognize language disorders again. This is performance well below age level and the IQ level. We're not sure what's going on with language disorder, and quite frankly, it appears that language disorder is actually probably a collection of disorders that share some things in common, but very likely may have separate causes. For that reason, or maybe because it's the nature of language disorders, the course is highly variable. Some disorders will continue for a lifetime, and some will be strong and powerful for a period of development and then decrease in intensity with or without treatment. Speech sound disorder is a disorder where there is problem making the precise sounds for words. The speech sounds slurred and uncoordinated. So it's very hard to listen to someone with a speech sound disorder. Speech therapy is helpful. In speech therapy here, you're working on getting a consistent cadence to the speech so that it's easier for people to follow it. Probably a variation of speech sound disorder is called childhood-onset fluency disorder, although you know it by another name. It's stuttering. Now, many people who stutter as children are able to overcome it as adults, including a lot of people that you see on television a lot. You would never know that they stutter. Stuttering is simply a repetition of sounds while trying to move on to the next sound. So they're trying to say a word, and one of the sounds in the word is being repeated. It's very embarrassing, and many people incorrectly believe that it's a sign of low intelligence. Stuttering seems to be unrelated to intelligence. It certainly increases in periods of stress or anxiety, so if you can manage the stress better, typically the stuttering will go down. And even in people who generally have overcome their stuttering, they may still stutter in situations in which their anxiety is high enough. Genes seem to play a role, although the exact nature of the role is not yet known. I'm not going to say a lot about this, but being able to speak is an amazing talent. We don't appreciate how amazing it is. We are talking about the coordination of dozens of muscles in our mouth, in our vocal cords, in our lungs, with split-second timing. A couple of milliseconds, thousandths of a second difference between where it should happen, when it should happen, and when it actually happens is enough to cause stuttering. It's amazing to me that we don't all stutter. This level of coordination is almost amazing. Many children with stuttering disorder will grow out of it. Actually, the evidence suggests they don't grow out of it, they just simply learn to control it. But there are procedures that are used in treating individuals, especially those with severe stuttering. Delayed auditory feedback, for example, trains the brain to process the information, auditory information, just a little later than it normally would, so it does not interfere with generating the next sound. And rhythmic cueing, which is to provide a cadence that one uses when they're talking, seems to create a template that makes stuttering less likely. Also recognized in this category is social communication disorder, sometimes called social pragmatic communication disorder, because we're not talking about writing the great American novel or tremendous oratory. We're just talking about being able to communicate to other people what you're feeling, what you need, what you want to do. This is often part of other disorders such as autism, and it can be found in individuals with learning disabilities as well. It often runs in families, and unfortunately, we don't know a whole lot about it. We're going to move on to another topic, the autism spectrum disorder. Now, the autism spectrum is actually a combination of two diagnoses that have been around for quite some time. A very severe disorder called autistic disorder, which fortunately is rare, but tends to have a very poor prognosis, and a much more mild disorder called Asperger's syndrome. Asperger is the person who identified it and first described it. This is more common, it's less severe, prognosis is much better, but it shares a lot with autistic disorder. Now, they've been combined partly because they share some common symptoms, and there do seem to be some core symptoms found in both of them. But the real reason that they were combined is they seem to share the same genetic diathesis. That is, the genes that cause the very severe autistic disorder seem also to contribute to the much more milder Asperger's syndrome. Now, we recognize autistic spectrum disorders, but I'm not going to present it that way. I'm going to present it as the two disorders that have been around for a long time, autistic disorder and Asperger's syndrome, and I'm going to talk about them separately, recognizing they belong on the same spectrum. And I'm going to do that because all of our research over decades is with these disorders separately. We have relatively little research where we have looked across the entire spectrum. Autistic disorder, very severe. It is, however, the best known of all the pervasive developmental disorders, even though it is probably one of the rarest of the pervasive developmental disorders. What do I mean by pervasive developmental disorder? Well, it's exactly what it says. It affects all kinds of things. Symptoms are very broad-based, so it's pervasive. It occurs early in the child's development and interferes with just about all of their normal development. Let's talk about the symptoms. We have severe abnormality in social functioning and communication. In many cases, without very, very intense effort, the children may never learn to use functional speech. That is, to use words to say, I'm hungry, or I need to go to the bathroom, or I'd like to go for a walk. Just tell people where they're at. And understanding speech, when someone says, put your shoes on, that they know what shoes are, and they know what it means to put them on. It also has dramatic symptoms that you can pick up from 100 yards. The facial expressions in children with autistic disorder are often bizarre. You can't really use any other term other than bizarre. Their body postures, their gestures, their movements are bizarre as well. They have very little eye contact, especially with your eyes. When we talk to one another, we look at one another. That's a very important part of what's going on. They don't seem to have that kind of social contact. And this is probably the most important, they find it extremely difficult to establish and maintain and use social relationships. They're not very good at communicating with other people, and they don't seem to appreciate that there's a reason to communicate with other people. By contrast, Asperger's syndrome is much less severe. There are social deficits. And what's interesting is those social deficits may be in someone who, in other respects, is quite adept. They might be very strong students. They can be good athletes, so they don't show the clumsiness and bizarre postures and movements that are found in severe autistic disorders. But they're almost clueless when it comes to social relationships. I'll come back to that in a minute. They can use language well, sometimes very well, but non-verbal cues are often missed completely. Now, most of us think that we communicate with language. You don't. And one of the problems of using text messages is you're only getting the language and you're often not getting the other things. We read people's faces all the time. And when the language doesn't match what the face is saying, we believe the face, and quite frankly, we're usually right. Language and cognitive development in Asperger's syndrome, however, are not affected. They are at least normal, in some cases well above normal. Now, we only recently realized that this much milder syndrome is part of the autistic spectrum. And there's a variety of reasons why we realized it. And I'm going to talk about several, not all of them, in later slides. The base rates for these disorders vary dramatically. The severe form of autism that we've recognized for decades is at most found in only 5 in every 10,000 people. Now, some references and some studies suggest it may be even lower than that, 1 or 2 in 10,000. It's mostly boys for reasons we do not fully understand. And what's particularly curious is often these are handsome boys. They look good. They're boys that can grow up to be, the kind of boy that could break your heart because they're just so handsome. And again, we don't understand why that's the case. The spectrum disorder, the other end, the Asperger's syndrome, occurs much more frequently. The best estimate is about 1%, but that's not a great estimate because we don't have very good samples that were randomly selected from the population. Again, they're mostly boys, although girls are represented more in this lower end of the spectrum than in the high end, where we have the very severe disorder. Severe autistic children are probably going to require lifelong care, although we now know they may not require lifelong hospitalization. If we can teach them functional use of language that improves their prognosis for being reasonably independent, but they're probably not going to graduate from high school or go to college or hold a job simply because it's well beyond their reach. People with the milder form often can function, especially if they are in a job that does not require a lot of social sophistication. So they might be, for example, excellent computer programmers, interacting with the computer very well, and perhaps interacting with some people they're collaborating with, but they're not very good at handling difficult social situations. So care of clients is going to be very hard for them because they have difficulty understanding where the individual is coming from and therefore responding appropriately. Again, we'll talk about why that might be the case shortly. Now, I want to talk about a topic that could go in more than one place. We could put savants as a topic under intellectual dysfunction or under autism because we see it in both cases. A savant is someone who generally functions at a very low intellectual level, but in some very narrow area, they function at an incredibly high level. They might, for example, be able to tell you the day of the week for any day going back 1,000 years or more. Now you might say, okay, well, that's kind of a simple program to write. It's not a simple program to write because we don't always have 365 days in the year. Every 4 years, we have 366. But every 100 years, we skip that 366th day. And of course, we shifted the calendar over time. So it's not a trivial thing to be able to do that. It's a fairly complicated program, but it seems effortless for savants. Some savants have amazing memory. They can tell you exactly what the weather was like for any day in their life. Or they may know the statistics. Some friends of my parents had 3 children who had mental retardation, 2 of them rather severe. One was a savant. He could give you the baseball statistics for anyone, for any week, going back decades, going back before he was born. Now, he didn't even fully understand what an earned run average was, but he could tell you what the actual earned run average was on June 15th, 1954 for a particular pitcher. If you've seen the movie Rain Man, you have an idea what a savant is. What in that movie was incorrect is that Dustin Hoffman, who played the individual with mental retardation, actually was a savant in several different areas, and that rarely happens. Now, the savant skills may be in other areas, not necessarily what we think of as intellectual areas. Some savants, for example, can listen to incredibly complex pieces of music and then play them, and play them perfectly. Now, perfectly is not the correct word because they will put every note in where it should be, and they can listen to complex chords and put each of the notes in, but they have no feeling. It's all very mechanical, almost computer-like in the way that it's done. Now, what do we know about savants? Well, they're fascinating. And what they show us is what we know about how the brain works. And how the brain creates cognitive skills is clearly deficient because we don't have a clue how you could have someone who is so bad in so many areas and can function at this unbelievable level in a narrow area. So again, sometimes we need humbling information. Just tell us how much we don't know. Okay, what do we know about the causes of autism? Again, I'm going to focus more on the severe autistic disorders here, but many of the things we're going to talk to apply to the entire spectrum. With the severe disorder, at one point, parents were blamed. And by the way, you can go on the internet and find lots of people who still blame parents because they don't have a clue. They really don't know what they're talking about. But on the internet, you don't have to know what you're talking about to put things down. That's why you need to be so careful when you read things on the internet. People observed that individuals with autistic children were often cold and showed flat affect. They didn't respond to very much. And they assumed that that's what caused the autism in their children, because children need contact. However, most of the people, parents, who had autistic children had other children. And those children didn't develop autism. Why not? Why would some children develop autism and not others? It never occurred to them that the direction of causation might be the opposite. You've got a beautiful child, and they're responding normally, and then all of a sudden they stop responding. You're holding your child, and your child's cuddling you while you hold them. God, what a powerful feeling that is. If you've held an infant recently, you know how they can warm your heart. And then suddenly they stop. And it often is very sudden. So it's like holding a sack of potatoes. Can you imagine how difficult that is for parents? How it might emotionally scar them? But the people who blame the parents never even considered that as a possibility. You may remember that we once blamed mothers for their children developing schizophrenia, the schizophrenic model of schizophrenia. This is another example of it. Again, no one takes it seriously now, but at one time people did, and that model is often described by many people on the internet as still being viable, even though it's not. We do know that people with autism are very sensitive to some stimuli, and perhaps for that reason will repeat behaviors over and over again because those behaviors are being heavily reinforced by their sensitivity to stimuli. An example, and this is common in severe autism, the child might sit at the toilet and reach up and flush it, and then watch the water swirl. Now you might say to yourself, that doesn't sound very interesting to me. Take a look carefully, especially when there's sunlight coming in. When the water swirls, it bubbles up. When it bubbles up, the light refracts off of it, and you see different colors, and they're in motion. Now, you probably don't even bother to look at a toilet being flushed. You probably have no desire to look at a toilet being flushed. But it is kind of fascinating. And for autistic children, it can be so fascinating that they'll do it sometimes for hours if you don't stop them. On the other hand, they're almost completely insensitive to what is probably the most important stimulus in our life, which is other people. We are social creatures. We connect to other social creatures. We do it from a very young age. When a mother talks to her infant, the infant looks at the mother's face where the voice is coming from, and then looks into the mother's eyes and communicates. It's like it's instinctive, but it's not in severe autism. They have difficulty understanding language. In fact, they're puzzled by messages. And it isn't that they don't understand the words. We call this theory of mind. The reason that you and I can talk with one another makes sense is I know that you're like me. You have a mind. Your mind's thinking things, and you may or may not be telling me what you're thinking. In fact, you may be telling me something that you're not thinking, or not telling me something that you are thinking. And what I try to do is I try to figure out where you're coming from by listening to your words, watching your facial expressions, and observe over time what you actually do. And I do that because, well, I know you're not a piece of furniture. I know that there are actions going on that I cannot see, your mind, that are responsible. What about genes? If you look at the textbooks 30 years ago, they all agreed that genes play no role in autism. No role. Your textbook and every other textbook tells you that the genetic contribution to autism is stronger than for any other disorder covered in this course. How did we get it so wrong? When parents have an autistic child, it's an enormous shock to them and an enormous strain for them to manage that child. And so what they typically did is they stopped having children. Now, when something's genetic, can we treat autism or the autistic spectrum disorder? I'm going to focus first on autism. The treatments that have been used are primarily behavioral. They were introduced by someone named Lovaas back in the 60s and 70s. They were quite controversial when he first introduced them. And over decades, we have taken those techniques and made them gradually more effective. What Lovaas did is he started by decreasing, through punishment, the self-injurious behavior that is often found in autism. I have seen autistic children who have run headfirst into brick walls, and you can see the split in their skull from having split it wide open from that. Now, I can't even imagine how painful that is. And imagine that there would be a lot of fear about running headfirst into a brick wall. But in fact, that's not uncommon. People with severe autism who do self-injurious behaviors now might be wearing a helmet to protect their heads from such things. He also focused on the functional use of language, teaching these children to be able to tell when they were too hot or too cold or hungry or wanted to go to bed or something like that. Took a lot of hard work to be able to do it, and often those programs were near colleges where graduate students and undergraduate volunteers served as the therapists doing this teaching. Now, we've also tried a variety of drugs. The SSRIs are modestly effective for some of the compulsive behavior, like flushing the toilet repeatedly. Neuroleptics seem to help a little with the social withdrawal, but again, they're a little less socially withdrawn, but they're not socially engaged. Beta blockers, which we know affects norepinephrine, seem to produce some positive results. Now, I want to point that out because there is no evidence that norepinephrine is involved at all in autism. In fact, there's more evidence suggesting that it is not involved in autism. So we don't know why a drug whose main effect is on a neurotransmitter that doesn't seem to be involved can produce such a positive effect. This graph shows the improvement in treatment from 1980 and before and 1980 and later. You can translate that roughly into pre-Lovaas, before his work, that has been continued in many, many clinics and labs since then, and post-Lovaas. What I want to tell you, first of all, there's absolutely no breakthroughs in that entire year, or that entire period, well over 50 years. But there have been gradual improvements, slow, steady improvements. and look at some of the things. In terms of overall competence, we get much higher levels, almost double the level of overall competence now compared to before Lobos. We get some improvement in language, not a lot, but some improvement. That's particularly interesting because Lobos focused initially almost exclusively on language development. But look at working. Could a person with severe autism do anything functional that's worthwhile enough to be paid for? A very small percentage, 1 in 20. But now it's like 5 in 20. It's a 5-fold increase in the ability to work. Can you live independently with autism? Unheard of prior to Lobos. It's still pretty rare, but you're talking about 1 person in 8 who can do it now. Over half of the people with severe autism prior to Lobos were institutionalized in a hospital 24/7. Now it's relatively rare. About 1 in 12, not 1 in 2, 1 in 12 require that kind of thing. Most can live in a halfway house or a living arrangement in a community setting where they can get support.